Hello students, I am Saili Rathod from International Center of Excellence in Engineering and Management ICEEM Aurangabad. Today I am here to present a video lecture of electrical measuring techniques, and the topic that we are going to cover today is universal shunt and multipliers. So students, in the previous two lectures we have studied the shunts and the multipliers, which we have used for the range extension of ammeter and voltmeter. Now, the advanced type of shunt and multipliers that we are using, which is called as the universal shunt and multiplier. These universal shunt are also called as the multi-range ammeters, and the universal multipliers are also said to be the multi-range voltmeters. So, previously, up till now, we have seen the shunt multipliers, potential transformers, and current transformers. All these were used for the range extension of ammeter and voltmeter. Okay, so today we will see universal shunt and multiplier. So let's start with the universal shunt, which is also called as the multi-range ammeter. So here from the figure you can see the basic meter RM is connected to the right hand side, and for the range extension of this meter we have connected the resistance, shunt resistance, in parallel with the meter. Now the shunt resistance that we have connected are four resistors R1, R2, R3 and R4, and there is a selector switch S. Selector switch is for the purpose to select the particular resistance. So depending upon the requirement, the user can switch the selector switch and connect to the required resistance. The selector switch changes the amount of resistance in parallel with Rm. The voltage drop across the parallel branches is always equal. So when all resistance are placed in parallel with Rm, maximum sensitivity of ammeter is reached. Okay, so all these four resistance are in parallel to the Rm. That is the basic meter. Let M1, M2, M3 and M4 be shunt multiplying powers for current I1, I2, I3 and I4. So from the above circuit we can write the formula for this shunt resistances. So for resistance 1, R1, we can write Rm upon M1 minus 1, where M1 is the shunt multiplying power. So Rm upon the shunt multiplying power factor minus 1 will give the R1. Okay, so this is the basic circuit for universal shunt and the formulas for the shunt resistance. Now the Itron shunt or universal shunt, it is a high resistance shunt which is used in galvanometer to increase their range without changing the damping. The circuit is named after its inventor William E. Itron. So this scientist have invented such type of universal shunt, so the name is given by his name. The multi-range ammeters that use this technique are more accurate than those using a make before break switch. Also, it will eliminate the possibility of having a meter without a shunt, which is a serious concern in make before break switches. Okay, so wherever the range is to be extended and the accuracy is needed, at that time we can use this universal shunt. So in the basic shunt voltmeter and this universal shunt, there is a difference of only the resistances which are connected in parallel with the basic meter. So now we will move ahead with some numericals which can be solved by using the formulas which we have just studied, that is R1 is equals to Rm upon M minus 1. So multi-range ammeter, a moving coil meter having internal resistance Rm is equals to 12 ohm and full scale deflection current of 20 milliampere. Design a multi-range ammeter and calculate shunt resistance for the following currents. Okay, so from this figure you can see the value of Rm, that is the meter range is of 12 ohm, and we have to design a multi-range ammeter which can calculate the resistance for the following currents. First is 500 milliampere. Okay, now for the first case 500 milliampere. As we know, the range of this ammeter is only 20 milliampere, but we need to calculate up to 500 milliampere. So we need a range extension of this ammeter. So what we can do is, we know that M MA equals to I upon IM. So now we can put the values, that is 500 milliampere means 500 into 10 raised to the power minus 3 divided by meter current, that is 20 milliampere. So 20 into 10 raised to the power minus 3. So after calculation we will get 500 upon 20, it will give 25. Now we got the value of M. Now we can calculate the value of shunt resistance. So RSH is equals to Rm upon M minus 1. Putting the value of Rm, which is given as 12 ohms. So 12 upon the value of MA that we have calculated 25. So 12 upon 25 minus 1. After calculation we will get 12 upon 24. So 1 by 2 means 0.5 ohm. So 0.5 ohm we got the shunt resistance for the first case. So range extension is done up to 500 milliampere. Now in second case we have to extend the range up to 1 ampere. So we have to extend range from 20 milliampere to 1 ampere. So following the same procedure, first we will calculate the MA. How we can calculate the MA? We will put the value of 1 ampere upon 20 milliampere. So 1 ampere upon 20 milliampere we will get the MA, and by putting this MA value in the formula of RSH we will get the shunt resistance, and the value will be 0.244 ohm. And the third case we have to extend the range up to 5 ampere. So for that purpose we will first calculate MA, and putting all these values in RSH you will get the RSH value of 0.048. Okay, so from these three examples it can be observed that if we go on increasing the range of that meter, the shunt resistance goes on decreasing. It means, for the first example, if you are extending the range up to 500 milliampere, the resistance was 0.5 ohm. Now from 500 milliampere to 1 ampere we have calculated, the resistance goes on decreasing and it is 0.24. And for the third one, if we want 5 ampere range, then the resistance we need is 0.048. So this is the multi-range ammeter. Now the second example, a 2 milliampere meter movement with an internal resistance of 300 ohm is to be converted into 0 to 100 milliampere. Means the range is to be extended from 2 milliampere to 100 milliampere. So calculate the value of shunt resistance required. Here the IM is given as 2 milliampere and the RM is given as 300 ohm. Now we have to calculate RSH and ISH. So ISH is main current minus the IM. So 100 minus 2. The range that we have to extend is 100, and the present range is 2. So 100 minus 2 is 98 milliampere. Now putting this value of I in the formula of RSH, so now we will calculate the M. M is equals to I upon IM, that is the range that we have to extend up to 100, means 100 upon 2, it is 50. Now putting this value of M in RSH. RSH is equals to RM upon M minus 1. RM, which is given 300, RM which is given as 300, and M minus 1, that is 50 minus 1. So 300 upon 49, it will give 6.122 ohms. Now we can calculate the RSH. RSH equals to IM into RM upon ISH. The value of IM we can put 2 milliampere. Then RM is equals to 300, and ISH that we have calculated 98 milliampere. By putting all these values, we got the value of RSH, that is 6.122 ohms. So this is about the ammeter range extension. Now the next example, a moving coil meter having a resistance of 8 ohm and gives a full scale deflection with 25 milliampere, means the range of this ammeter is 25 milliampere. How we can use it to measure the current up to 2 ampere? So range we have to extend from 25 milliampere to 2 ampere. IM is given as 25 milliampere, I is given as 2 ampere, that is 2000 milliampere. RM is given as 8 ohms. Now we have to calculate RSH and ISH. So ISH, firstly we will calculate by subtracting the IM from the main current. Main full scale deflection current is 2000 minus 25 milliampere. After subtracting this, we will get 775 milliampere, that is shunt current is 775 milliampere. Now by calculating M, that is I upon IM, I is full scale deflection, that is 2000 upon 25, it will give 80, and by putting the value of M in RSH, so RSH equals to RM upon M minus 1, RM is 8 and M minus 1, that is 80 minus 1, it will give 0.101 ohms. So here by using this formula we can calculate the shunt resistance. The alternative method or the formula is also given here. So the concept is same, you can just use any technique to solve the RSH. Now we will move ahead with the multi-range voltmeter. As it is similar to the multi-range ammeter, here we have connected the shunt resistance in series with the basic meter. The addition of a number of multipliers together with the range switch provides together with a workable range. A multi-range voltmeter using 4 position switch and 4 multipliers R1, R2, R3 and R4 for the voltage range V1, V2, V3 and V4 respectively. The multiplier resistance can be calculated by the following methods. Okay, so these 4 resistances are used and a selector switch, that is S, is connected, which can select the required resistance depending upon the user's requirement. Now RS is equals to RM M plus 1, where M is given as V upon Vm and Vm is equals to Im into Rm. Okay, so this is a multi-range voltmeter. We will see one example and then we will stop with this topic. The basic PMMC instrument with an internal resistance of 100 ohm and full scale current of 1 milliampere is to be converted into 0 to 10 volt voltmeter. Im is equals to 1 milliampere. Okay, 1 milliampere is given the full scale current, that is 1 into 10 raised to the power minus 3. Rm is given as 100 ohms. Vm is equals to Im into Rm. So 100 milliampere into 1 milliampere will give 0.1. Now putting this value in M, that is V upon Vm. V is given 10 upon Vm, we have calculated as 0.1. So after calculation we will get the value of M, that is 100. Now we can calculate the shunt resistance. Shunt resistance, that is Rm M minus 1. Value of Rm, that is given 100 ohm and 100 minus 1. So 100 into 99, that is 9900. It means 9.9 kilo ohms. We have got the shunt resistance. Okay, so there are basically two formulas only. By using these formulas you can calculate the shunt resistance, the value of Im, Rm using these two formulas. Okay, so two types of multi-range ammeter and voltmeter we have covered in today's lecture. So we will start the next video lecture with a new topic. So keep studying and thank you so much.